Now you're given a task of drawing these two molecules here. So how will you approach it? Step number 1, always look at the parent chain first, hex 3 in. So in your mind, we know that there must be one straight row of 6 carbon atoms, and between the third and the fourth carbon, it exists a carbon-carbon double bond. And for the third and the fourth carbon, there is also a fluorine atom coming out of it. Now take note that there's a Z isomer, so there must be some form of geometric isomerism. I hope you got this right. This is represented, alright, skeleton structure of the top molecule. How do we know this is Z? Because the same part, the fluorine are on the same side, below the double bond. Or you can tell yourself that, oh, these are ethyl group and ethyl group, they are identical and they are on the same side. So that makes a Z isomer. Hex 3 in, so let's go 1, 2, 3. Between the third and the fourth atom, there's a double bond, correct? And third and the fourth atom, there are fluorine atoms. So this is fine. Now suppose you are asked to draw the cis isomer instead. They do not use E and Z. So how do you do it? Right. So we know that this is cis based on the fluorine, and the ethyl is cis, right? So for Z, we cannot look at the identical groups. We need to look at each carbon and see whether which is of a higher priority. So fluorine is of an atomic number of 9. Carbon here, atomic number of 9. We do not take the whole group, not whole entity, but just one atom by atom, and we compare. So carbon here is a 6, so 9 beats 6, so check the high priority one, and they're on the same side, so it is Z. This example shows you that sometimes these two names give the same structure, but there's a hidden question here. If the reverse process is being asked to you, you are asked to write down the name of this molecule, then which one is acceptable? The answer is both are acceptable, but which is more preferred? It's the first one, the one that you use the Z or E denotation. The reason being, cis and trans aren't specific. They do not tell you the exact position at which this is cis and trans. We have to assume it. So in this case, there is no choice but between this carbon-carbon double bond, it is cis or trans. There's no other double bond. But in more complex molecules, there could be many double bonds, and you just can't put cis, trans. Nobody does that. You have to use E and Z labeling for the individual double bond. So once again, if you have a choice of using EZ or cis-trans to name a molecule, please stick to the EZ notation.